Welcome to Brain Vision.
Here's our function z, and we can see that it's a function of two variables, x and y. And let's go ahead and find the values delta z and dz. So using formula 7 from this section in the book, we would go ahead and take so the general formulas, let me just write that out. So in our case, this is a comma b, and then delta x is the final x value minus the starting x value. In this case, the final y value minus the starting y value. So here we'll go ahead and plug these into this formula here. So we'll have basically f of the final point, the terminal point, minus f of the original point. So now we'll carefully write this all up. So let me use brackets to separate these. So for the first one, here's your x. You square it, minus x times y plus 3 and then y squared. And then subtract f evaluated at 3 minus 1. That gives you x squared minus x times y plus 3 y squared. And going into a calculator, I have negative 0.7189 for delta z. Next one up is dz. This is given by formula 10, same section. So you can see it's a different looking formula. And here, right after formula 10, it's mentioned that we can just go ahead and take dx to be delta x, dy to be delta y for these types of problems. And then in this case, and the reason for this is because if x is small, then these two are indistinguishable. So we'll need partial derivatives here, fx. So use the power rule here. You have a 2x and then minus y. And then you'll plug in the point 3 and minus 1. So that gives you a 6 minus negative 1, which is 7. And then multiply that by delta x, negative 0.04. Plus, now we need partial derivative with respect to y. And this one will be 6y minus x. So go ahead and plug in the point 3 minus 1. And so you'll have negative 6 minus 3, giving you a negative 9. And then delta y, that one was 0.05. So now we go ahead back to the calculator and crunch all this in, and we'll have negative 0.73. And we can see that if we compare these values, they're relatively close to each other. And the reason for that is that delta z approximately equals dz as long as the change in x and y is not too large. And we can see here the change in the x's is pretty small, and also the change in the y values. And so that's our final answer.